So let's go ahead and work through some of these homework problems here. So I'm going to start, and for these first four problems, we're doing the exact same thing, finding the total resistance, finding the total current or voltage, and then the voltage and current on each resistor. So I'm going to start, of course, by looking for simple combinations, and I see that right here. I have R2 and R3, so I can say 1 over RT equals 1 over 20 plus 1 over 5 because they're connected in parallel. I go ahead and I combine those, and I get that my total resistance here, the combination of 2 and 3, is going to be equal to 4 ohms. And then I can go ahead and redraw my circuit, replacing that resistor with a 4 ohm resistor. So I still have R1 here, which is 6 ohms. And then I have R23, which is 4 ohms, connected to this 100 volt battery. I then find the total resistance of that combination. They're connected in series, R1 and that combo of 2 and 3, so I'm just going to add them up, and I get that the total resistance of this circuit is 10 ohms, which answers question A. From there, I can go ahead and find the total current, which is the current leaving the battery, and I'm going to do that by doing Ohm's law, V equals IR. So I can say 100 volts equals the current times my 10 ohm resistor, and I end up finding that my overall current running through this circuit is going to be 10 amps when I solve for that. I then can go back and apply the voltage and current for each one. So that 10 amps that leaves the battery is going to go through both of those resistors there. As it travels around the circuit. So this resistor will get 10 amps, this resistor will also get 10 amps. Then using Ohm's law, I can solve for the voltage across each one. And so we're going to keep coming back to that one, but most of these are designed to be relatively quick math you can probably do in your head. So we're going to say our voltage is current 10 times resistance, which is 6. So this one gets 60 volts, this one gets 40 volts using that same equation there. Okay, I can then step this back to my previous example here. This R23 came from combining 2 and 3 in parallel. I know that resistors that are combined in parallel each get the full voltage, so I can say that R2 is going to get 40 volts and R3 is also going to get 40 volts. I can then use V equals IR once again to get the current. So 40 equals 20 times I, R2 is going to get 2 amps. 40 equals 5 times I, R3 is going to get 8 amps. And so those are my answers for that. And then for R1, that one didn't change, so that one's going to be 10 amps and 60 volts. All right, moving on to my next circuit here, I'm going to find the simple combination, which once again is this R2 and R3. They are connected in parallel, so we're doing the 1 over equation. So we can say that total resistance is going to be 1 over 12 plus 1 over 4. So we get that R23 together has a resistance of 3 ohms. We can then go ahead and redraw our circuit here. And replace it. So we have our battery, which here we're not given the voltage, but instead we're told the current is going to be 5 amps. But that's okay, we'll be able to get the voltage once we have our total resistance. So we have R1 there, R2, 3 here is going to be that 3 ohms that we just solved for. And lastly, we have R4, which is 10 ohms. And we know that there's 5 amps of current leaving the battery. This is all connected in series now, and so we can say our total resistance here is just going to be the sum of those, 7 plus 3 plus 10. So we end up with a total resistance here of 20 ohms, which is the answer to that first question. What is the overall resistance of the circuit? We then can use Ohm's law to get the voltage in this case, because we're given the current. So we can say V equals IR. Our voltage then will be our current, which we know is 5, times our resistance, which we just solved for is 20, and so we get 100 volts for our voltage. Alright, so we're now going to work backwards to get the voltage and current on each individual resistor here. And so, as we said, this 5 amps is what we know the current is going through it. Because this is all one big series, that 5 amps is going to go through each one of these resistors. And then we can go to Ohm's law to solve for the voltage across each resistor. So we're coming back to this equation time and time again. And so we can say V equals IR, this voltage is going to be 5 times 7, or 35 volts. This voltage is going to be 5 times 3, or 15 volts. And this voltage is going to be 5 times 10, or 50 volts, which we do see adds up to the full voltage of 100 volts. I'm going to go ahead and any resistors that were original ones, which in this case would be R1 and R4, I'm just going to put those values back on the side here. There's no sense in continuing to copy those values if they're going to be the same. So we know the current for both of those is 5 amps, and we know that this one has a voltage of 35 volts, and this one has a voltage of 50 volts. We're then going to step back. This R23 came from these two connected in parallel. Because they were connected in parallel, we know that each one will get that full voltage of 15 volts. And then we can use Ohm's law, all right, our equation down here once again to solve for the current that's running through each one of those circuits. Okay, and so we end up finding when we do that that this current here is going to be 3.75 amps. And this current here is going to be 1.25 amps. That just comes from Ohm's law there. That makes sense because those add up to the full current of 5 amps that gets split between those two in parallel. And so then we can fill in our final few answers here. 3.75 amps, 1.25 amps, and they both get 15 volts. Alright, for this next one here, we have a few more resistors, but the basic idea is going to be the same. I'm going to start with this combination here in series. So we're just going to add them up, 10 and 20, and we get a total resistance for 5 and 6 of 30 ohms. Same thing with this combination over here. They are connected in parallel. So this could be 1 over 40 plus 1 over 10. So the combination of 1 and 2 gives me a resistance of 8 ohms. We're then going to go ahead and redraw our circuit here, replacing those resistors with the ones we just found. So here's our 60 volt battery. R12 here is going to be 8 ohms. We then still have R4 here, which is 20 ohms, connected to R56 here, which is 30 ohms, and then that all comes around to connect to R3 down here, which is 10 ohms. Our next simple combination that I'm going to find is these two are connected in parallel, and so we end up with 1 over 20 plus 1 over 30, and so we get that the total resistance here and that's going to be for 4, 5, and 6 combined, is going to be 12 ohms. And then we're going to redraw our circuit one last time here, replacing that final one. So I have my 60 volt battery. We have R12 still, which is 8 ohms. We just found that R456 is 12 ohms. And that's connected here to R3, which is 10 ohms. For my final step then, these are all just one big series here. And so I can just add up all those resistors, 8 plus 12 plus 10, and we get a total resistance here of 30 ohms. So that was the first step there, getting that total resistance. We can then go ahead and solve for our total current using Ohm's law, V equals IR. So 60 equals the current times that resistance of 30, and we get that our overall current, leaving the battery here, is going to be 2 amps. We're now going to work backwards and fill in the voltages and currents for each one. All right, so working backwards, I know that 2 amps is going to leave the battery, and since all 3 of these are connected in series, I know that 2 amps will go through each one of those, and then using Ohm's law, V equals IR, we can get the voltages. So 2 times 8 means that this is going to be 16 volts, 2 times 12 means this is going to be 24 volts, and 2 times 10 means this is going to be 20 volts. We do see that they all add up here to 60 volts, as they should. And so I can fill in R3 at least. That one is an original resistor. Okay, it wasn't a combination, so I can say that R3 was 2 amps and 20 volts. I'm now going to step things back, okay, to the previous one. And so I see that this R456 came from those two connected in parallel. Because they were in parallel, we can say that R4 and R56 will both get that full 24 volts. So this one is going to be 24 volts, and this one is going to be 24 volts. We also can say that this R12 is still 16 volts and 2 amps. Using Ohm's law then, I can get the current for these two. So again, V equals IR, we can say 24 equals 20 times I. So this current here is going to be 1.2 amps, and this current here is going to be 0.8 amps. That allows me to fill in for R4. All right, so I'm going to do that over here where I'm just keeping my tally of all of the voltages and currents that I know. So 1.2 amps and 24 volts. And then we can step this back one step further. And there are 2 circuits that came from combinations, or 2 resistors that came from combinations. So this R456 came from 5 and 6 in series, and this R12 came from 1 and 2 in parallel. So starting with 5, 6, I know that because they're connected in series, each one, both 5 and 6, will get that 0.8 amps of current. And then I can solve for the voltage. So this one is going to be 8 volts, and this one is going to be 6 volts. Again, going back to V equals IR time and time again. Looking at the 2 in parallel, each one of them will get that full voltage, and the current will split. So I can say that R1 will be 16 volts, and R2 will also be 16 volts. And then I can go ahead and solve for my current. So the current through R2, using V equals IR, will be 1.6 amps, and the current through R1 will be 0.4 amps. So we see how that 2 amps that went through here gets split. And so then I can fill in the final values over here. Obviously they're all listed, but just to have everything in one spot, R1 is 0.4 amps, R2 is 1.6 amps, R5 and R6 are each 0.8 amps, and then we can go ahead and fill in our voltages as well. So we know that this voltage for 6 is going to be 16 volts, for 5 is going to be 8 volts, and then both R1 and R2 are 16 volts. And so there's your final answer. All right, moving on to our last circuit analysis. First, going to combine R1 and R2. They are connected in parallel. And so when I add them up, I get that R12 together is going to have a resistance here of 16 ohms. And I also have R4 and R5 over here that I'm just going to add up. So 40 plus 120, because they're connected in series, and so I find that R45 is going to have a resistance of 160 ohms. I'm then going to redraw my circuit, and so when I do that, we're going to have our battery over here this time, 24 volts, and that's going to be connected. So R3, that one hasn't changed. That's just 40 ohms in the middle here. Down here, I'm going to have R12. which is going to be 16 ohms as I found. And then we have the combination of 4 and 5, so R4, 5, which is 160 ohms. I'm then going to look for my next simple combination here, and that's going to be these two. They are connected in parallel, so I can say 1 over RT is going to be 1 over 60 plus 1 over 40, and I get that my total resistance here, combining 3, 4, and 5, is going to be 32 ohms. And then we can redraw one last time here, and then it will just be a basic series circuit. So what we'll have is, here's our 24 volt battery. We're connected over here to R3, 4, 5, which is 32 ohms. And then down here we have R1, 2, which is 16 ohms. I then can do that final combination. They are connected in series, and so the total resistance here will just be 32 plus 16, which gives me a total resistance of 48 ohms. So that answers question A. For question B, we're going to use Ohm's law. V equals IR. So 24 equals I times 48. My current then is going to be 0.5 amps. Alright, so we're going to take that current now, that's 0.5 amps. We know that that current's going to leave the battery and flow through both resistors here. So we can go ahead and apply it to both. So each one will get 0.5 amps of current. And then the voltage comes from Ohm's law, multiplying that current by the resistance. And we get that this one, 16 times 0.5, has 8 volts. And this one, 32 times 0.5, has 16 volts. We can then step this back one. This R345 came from combining these two in parallel. Since they were combined in parallel, we know each one will get that full voltage there of 16 volts. And then we can use Ohm's law once again to get the current. And when we do that, we find that this one will have 0.1 amps of current, and this one will have 0.4 amps of current. Of course, the R12 here still has 0.5 amps of current and the same voltage it did, because nothing changed between these two steps for that resistor. So R3 was the original resistor, so I'm going to fill in what I know for R3. We said it was 16 volts and a current of 0.4 amps. And then we're going to step this back one more, and there's two combinations we had going back one more. So R4, 5 came from 4 and 5 in series, and R1, 2 came from 1 and 2 in parallel. Starting with 4, 5, they are connected in series, which means each one will get that current. So that means this one has 0.1 amps of current, and this one also has 0.1 amps of current. We can then solve for the voltage using Ohm's law, V equals IR. So this one's going to be 12 volts, and this one is going to be 4 volts. And we can fill that information in over here. So R5 was 12 volts, R4 was 4 volts, and each one got 0.1 amps of current. We can then do the same thing with our two that are connected in parallel. So we see that each one of those had 8 volts, right? Because whenever they're connected in parallel, they both get that full voltage. We can then solve for the current that each one gets. So we find that R2 is going to get 1/3 of an amp, or 0.33 amps, and R1 gets what ends up being 1/6 of an amp, which I'm rounding a little bit, but 0.17 amps. So we can fill in those final two. So R1 gets 0.17 amps and 0.33 amps for R2. And then the voltage across each is 8 volts. And so there's your final circuit analysis. Again, that's probably about as bad as you're going to see it with 5 resistors or maybe 6 like in the last one, but nothing more than that for sure. All right, so for this last question, you don't actually have any numbers, but what we do have are 5 identical resistors arranged in this circuit that we see down here. And we want to rank the current going through each resistor from greatest to least. So I'm going to think about the current leaving the battery. That current's going to leave the battery. It's all going to go here through R5 and then come up to this junction. And then it's going to split. Some is going to take this green pathway. The rest is going to take this red pathway. It's going to go around, all right, the red pathway will continue through R3, the green pathway will continue through R4 and R2, and it all comes back together to reunite at this junction to go through R1 and complete the circuit. So what we see right off the bat, if we want to go ahead and rank these from greatest to least, is both R1 and R5 get the full current. All current flows through those two resistors, all right, because they are either before the split or after the current has come back together. So I can say for sure that R1 and R5, not only are they equal, but they're the biggest two resistors. I then want to think about R3, which is on this branch here, along with R4 and 2, which are on this branch here. Okay, and there's a few ways of thinking about this. We can think about the voltage, all right, or what I think is actually easier is thinking about the resistance. So this branch, all right, of R2 and R4 together, that branch is going to have more resistance, all right, and since there's more resistance, that ultimately leads to less current. Right? So that's one way of thinking about it. The other is we know that from the time it splits here until the time they come back together, we have to have the same voltage across both. Right? Because there's two resistors on this branch, they will share that voltage. So each of those resistors will get half as much voltage as R3, where there's only a single resistor. Either way, it points to the fact that we will have more current through R3 than we do through R2 and R4. They will be less current because they have more resistance or because there's two resistors and therefore they have to share the voltage. So what that means is that R3 is going to be the next biggest current, and then R2 and R4 are equal because they're in series, one right after another, and they will be the least current. And so there is your ranking from greatest to least.